All right, today we'll be working on section 813 with solving equations on logs and exponentials. But to do that, we need to just first remind ourselves how we do the condensing. So if you would, just take each of these and write them down on separate paper and try condensing each one. You can pause the video here. When you are done trying each of the four, come back and check your work. All right, number one, we should have had, first off, taking the 1/2 coefficient, making it an exponent. And when you make it an exponent, the 16 to the 1/2 power is like square rooting. So square root 16 would be 4. Then the log base 3 for the addition here would combine to a log base 3 of 20 because we'll multiply those two inputs, 4 times 5. For the second one, again, make it an exponent in both cases, both coefficients. So first off, it would be a to the 7th, then it would be b to the 8th. Then we're subtracting two logs of the same base, so they'll become a quotient. So a to the 7th over b to the 8th becomes a singular input. And number 3, again, we want to use the exponent rule. And the exponent rule is going to give us 9. So if I do 9 times x minus 8, you could rewrite it if you want to. 9x minus 72 would be another way to write that. But the exponent happens first, and then the combination with the multiplication there. And finally, if I work on this last one, I'm taking 48 and 3 and dividing them because of the minus between the log base 8s. And the one over here is going to become a third power, so I have 27. And I don't want to just multiply 16 times 27 because order of operations would have me work on this first log first. So what I do is take the 1/2 power, that makes 16 become a 4, square rooting it. And then the 4 times 27 gives me 108. So we should have log base 8 of 108 as our final answer there. All right, so let's work on one expansion. So again, just write down the log on that same sheet of paper. Work on expanding it using all of your properties. We'll expand it as far as it'll go. Pause, and then come back here and check. Okay, so for the first part of the expansion, I decided to take the quotient and turn it into a subtraction of log base 7s. So you can see that this first log base 7 is the numerator log, and I just changed it to a fractional power because I thought that would be easier for the next step of expansion. And then the denominator became the second log base 7. Now within that denominator, after the minus sign, what I'm doing here is splitting it into a sum because this is a log of a product, and a log of a product can be split into a sum of those logs. So it's s squared, and it's t to the 3rd to the 1/3. And so there's a plus sign between them, but all of it's grouped together because of the minus sign that came before that log. It needs to stay before the sum as well. So the next step, take that 1/2, bring it in front of the first log. Take the square and bring it in front of the second log. And then the minus can apply to it. Take the 1/3 and bring it in front of the third log, and the minus can apply to that as well. And then we have our fully expanded log. We can't do anything with this first log further because remember, it's the sum of logs that can be condensed, not a log of sums. So this is considered complete. All the exponents are down in the coefficients. We've expanded that fully. All right, so let's work on some log equations. So we'll go through a few of these and try to get it so that you can do some on your own. So there are some steps listed here. In the first type, what we're seeing is when a log equals a log. What we want to do is, in order to get it to be a log equals a log, we have to do our condensing fully. And once we have everything fully condensed, so we have a singular log on both sides, we can use this 1-to-1 property, which says that if we have two logs of the same base on either side, then what's going to happen is the inputs are going to be equal to each other. So if log base b of m equals log base b of n, the only way that can happen is if those two inputs are the same. All right, so that's how this first one is set up. They're both log base 5, so all I need to do is set the inputs equal to each other and solve it. So if I solve this, minus 5x gives me x equals 9. And you can always go back and check it and confirm that you did, in fact, get that the two sides are, in fact, equal when you use 9 for x. All right, so that's one way these can be. Another way these could be is that you could have two logs on the same side and need to condense it to a singular log. Now we can condense these because they're both log base 10s. They're implied as base 10. So because of the plus sign, what I'm going to do is multiply these two inputs. And I'm going to call this log of 4y plus 20. That's just multiplying the 4 by the whole y plus 5 binomial equals log of 72. And so now I have log equals log, both base 10. So I can just write 4y plus 20 equals 72, and I can solve from there. Minus 20 is 52, divided by 4 is 13. All right, and again, go back and check it to confirm it, but that is the final result there. In exercise 5, now I have a coefficient, so I would want to condense that log by making it log base 7 of 4 cubed, which is 64, equals log base 7 of 4a minus 8. So by bringing the coefficient up to the exponent, I've got it so that log equals log. So therefore 64 equals 4a minus 8. And I can add 8, get 72, divide 4, and a equals 18. I just want to backtrack for a second back up to number 3 to show you an example of where we might run into a no solution situation. So I have a log on both sides, so I can just go right ahead with 6 minus 3w equals negative 2w. If I add 3w to both sides, I get 1w equals 6, so w equals 6. But if I take that 6 and I insert it into either one of these logs, I'm going to end up with a log of a negative. And remember, we can't have negative inputs on logs because that implies that when we applied an exponent, we got a negative answer, and that doesn't happen. So log inputs can't be below 0. They can't even be 0. So if you ever get an answer that when reinserted creates a negative, that would be considered an extraneous answer. And so we want to be on the lookout for any time the solution creates a negative input to a log. Now that number wasn't negative itself, it's just that when we applied to the log, it became a negative input. So that's why we have no solution there. All right, we will do one more on this page and then move on. So number 8, I've got a singular log on the left, but I don't have a singular log on the right. So I think I'm going to work on this one first. Bring that 2 up to the power. I'd have 6 to the second power, which is 36. And then I have subtraction, which indicates a quotient. So if I do 36 divided by 4, I have log base 3 of 9. And so I just am ready now with a singular log on both sides. So I can take the two inputs and set them equal. So 2p minus 5 equals 9. Add the 5, get 14, divide the 2, p equals 7. And just a quick check back here, that would not create a negative input, so that one's good. All right, so on to the next section, page 13. All right, so in this one, I do have a singular log on both sides, but when I go to write the equation to make them equal to each other, I get a quadratic. So when you have a quadratic, remember one side has to equal 0 in order to solve it. So you move it that way. Then you do your factoring. We get 9, n plus 9 and n minus 2. So negative 9 and positive 2 are my results. But I do want to go back and check it and make sure that neither one of those creates a negative value, right? So negative 9 times negative 7, that's positive, that's fine. Negative squared is fine. Put a 2 in here, I get 18 minus 14, that's fine. So neither one of these created an extraneous solution, even though I did get a negative there. I just want to go back and check that just to be sure. Okay, now on to the next category here on page 13. We have when a log equals a number. And what we basically want to do with these, if you don't have multiple logs in an equation, you just want to rewrite it as an exponential, and then you'll be able to solve it. Because if I have a base, an answer, and an exponent, if I just put that exponent on the base, that's going to be a single number, right? 2 to the 6 is just 64. And so if I add 4 to both sides, I get 68. So these are actually easier to do. Sometimes they have a couple extra steps to them, but they're not too bad if you can remember the conversion steps. So for this one, you do have to have an isolated log before you can do that. So I'm adding 7 to both sides and getting 4. And now I can take 3 to the 4th power and set it equal to the input, 4x plus 8. So this is 81. 81 minus 8, divide 4, end up with 73/4. Or you could call it 18.25 if you prefer. But just remember, if the decimal does not terminate, then you do need to keep it as a fraction. So we could have a couple ways to write that one. All right, so this next one, if I'm going to do this log equals a number and use the exponent concept, I do have to condense these two logs on the left. So because it's a plus, it's a product. 2x times x minus 5 is going to be 2x squared minus 10x. But it's still a log because the condensing says condense the sum into a product of inputs. So my base is 10, my power is 2. So I'm going to have 10 squared. And then it's quadratic, so I need to move everything to one side. And at that point, I can divide. And then from this point, I'd like to factor further. So that x squared minus 5x minus 50 is going to be x minus 10 times x plus 5. I get 10 and negative 5, but this time the negative 5 is problematic because if I put a negative 5 into either log, it's going to create a negative input. No problem with 10, but negative 5 does not work. So negative 5 is considered extraneous. We just want to make sure we check for that each time. All right, and number 16, the last one we need to do here. So I have a pair of logs on the left side. That's going to give me a product again. So it's log base 10, so 10 to the first. So if I subtract the 10 to make a 0, I'm going to have x squared minus 3x minus 10. It factors into minus 5 and plus 2. Answers are positive 5 and negative 2, but the negative 2 has, it creates a problem with both logs. Neither one of those comes out positive if we use negative 2. So just check it at the end, and you should be good there. All right, refer to the notes on Google Classroom for the rest of your assignment here, and you can come back to these notes whenever you need to.